Today we're going to see this model of this hydraulic system that you see on the screen. And the idea here is that we would like to outline some steps on how to do hydraulic systems. And then we're going to go enter those into the CAMG software. So here we have a system. As you can see here, I'm going to show this a little more cleanly here. We have a tank in here, and we have another tank in here, and a valve in here, and a discharge on the side. This would be a intake flow in here. So I'm going to put this in the in the form of this handout that I have prepared with the different steps. So you see the first step, it says recognize the elements that make up the system. So here the hydraulic inertias are I, C's, R elements. This is, ignore this one in here because it's a typo in here. We need to have a C element in there. So that would be the only thing I make observation about this one. But we're going to try something new, and that is we're going to sort of fade out the system in the background and actually try to make a showing that the bond graph has a one-to-one correspondence with the physical system. So for that reason, you see the first step after recognizing the elements, we're going to draw on the system itself, on this system, dotted out silhouette, you may say, of the original system. Put the one junction for each distinct flow. So here you have one, and then you have one in between here, and then we have the discharge flow. We're not considering resistor inertia on this side of the pipe because it's a small one in this. But we have two tanks, which are C elements in there. And in here, the first thing we're going to do is put a one junction for each distinct flow. Having done that, we go to step number 3, which says attach to the one junction the, the, the physical elements that experience these volume flow rates. So this includes the sources and sinks, and note that at the end we need an active bond because basically we are saying that the pressure here is 0 and this is free flow. Yeah. So here we go. The first we attach a element in here. This flow. We attach the inertia and the resistor over here. This resistive valve here, and this is the activated one, which means a source of effort with a F4 equal to 0, which would be my atmospheric pressure reference here. So we're beginning to set up the procedure to build the bond graph model, and that is step number 3. As you can see, you can see it in here. We have put the elements that see those volume flow rates. Now we're going to represent the differences between the volume flow rates with 0 junctions. These are the relative volume flow rates that are expressed in here. So it's very obvious the water is coming in, and it gets accumulated some in this tank, but some will go on. It's accumulated in this tank also, and some will continue. So this is the situation here. We use the 0 to make the difference between these two flows, and that's what goes into the tank. The difference between this and this is what goes into this tank. So it's beginning to take shape, and here you can go and see on the next step we attach the elements that see those differences, like the tank here and the other tank over here, and we're done. So when we put this into KMG, we are going to see something like this with the numbers, the causal forms, and everything that we need. This is a description of this hydraulic example. So if you get it to the stage, the prior stage as indicated over here, this is basically the same thing as what's down in the program. The difference is that when you enter this into CAMG, what happens is that the computer um, numbers the bonds and puts the causal marks, and that's the tremendous advantage of that. And I think little by little, I'm letting you more use the software and be towards the automated process than trying to do everything by hand. So why don't we study here using this example how we go about obtaining the state space matrices and also obtaining not only the state space matrices A, B, and, but also the C and the D matrix. That is important to do. So we need to enter this into the bond graph, into CAMG, and ask CAMG to produce the state space form for me. And not only that, produce state space form for me in the form of the AB matrices, but also the output equations, which are the C and the D matrix. So why don't we just do that? First, you following this procedure, we put together this bond graph model. Now we go ahead and enter it in the software, and we have to go on from there. So what I would do is, let me make a reduction of this. And we're going to enter it there. Okay, so let's just go ahead and enter this into CAMG, and we will see where we go from here. Okay, take a look here. This is a file. We're gonna say, okay, this is new. I am going to enter this over here. So SF, and then we have a 1. And then there's a 0. And then we have this. Okay, so we have all those. Oh no, did we click on the wrong element in here? It's not an element, it's a C, so we need to undo this. And of course we need to delete this R element and instead put the C element in here. And then we go on to this one over here. Yeah, then we're fine. And then we have to put the I and the R of down here. Okay, so now we move over here, and then the C element. And then we have an R element and an SC. Okay, this is the bond graph map. So here we have seen that this contains equations and all that stuff. You may recall if you go to analyze and to pick, it will allow you to see the equations of the system. So now we're going to run this MATLAB interface. So we have to wait a little until MATLAB comes up and brings us and sets up those files for us. And that will help us get the state space from using the CAMG program. And there we go. So we have MATLAB open, and then we have these files. I think you would be surprised to see that if you go to a CAMG SYM and you click on run, watch what happens. Look at the command window on the yeah. Okay, so here we CAMG. If you click on run, watch what happens on the right hand side over here. See? Computer immediately knows the input vectors, the state space variables, how many equations it's going to derive, and the matrix in symbolic form, the A matrix and the B matrix. Okay, so just by running that file, we obtain the A and the B matrices. But how can we get it to do the C and the D? The C and the D have to do with the outputs. So what we need to do is to define an output on the system in here and then go with that. Maybe let's add two outputs. So I would like to do two output matrices and two rows in the output matrix. So if we go back to the bone graft model, we could talk. Well, I guess we have it in here. It's a matter of yeah. You have this is the A matrix, the B and the C and the D. So the A matrix is symbolic, contains all the physical parameters. The B matrix is also symbolic. So now I need to tell the computer what my outputs are. So to do that, we need to go back to the um, go back to the original document, which is over here.